This is the AIPMT 2015 question from the chapter Friction. The problem is like this. A plank with a box is on one end of it is gradually raised from the other end. At an angle of inclination of 30 degree with the horizontal, the box starts slipping. Let's think of that part itself first of all, right? When body starts moving on a inclined plane at a particular angle, that angle is called angle of repose. Angle of repose. We have proved that angle of repose mu equal to tan theta. I'm not going for the proof. I have already proved it in the chapter friction. You can find that in frictions playlist. Do find it out, please, right? So how much is that mu static is? Because there it has just started moving. Tan at an angle of 60. Sorry, 30. He has given it as 30. Tan 30 is 1 by root 3. That's 1 by root 3 is 1.712. Then if you calculate that value, you will get approximately 0.6. So you got mu static from the first, that is there as here as well as here. You want to calculate what is the coefficients of static and kinetic friction. I have already calculated static friction. What's the other part of the problem? It slides 4 meters down on a plank for a time of 4 seconds, right? So it is sliding down. It is sliding down. As it is moving down, we have proved that when body is sliding down the rough inclined plane, again I am not deriving the equation. I have proved that already. In the playlist you can find a derivation for it. A equal to g of sine theta minus mu cos theta. That's the derivation that we have made already. We can see that g of sine theta minus mu of cos theta. Now once if you know the acceleration, it is covering a certain displacement on the inclined plane. Yes, on the inclined plane, this much. That is can be found using a formula ut plus half at square. I can try writing even v square minus e square equal to 2as, but he has given s and a t. That's why I am writing an equation that is there in both of them. S is 4, u is 0 starting from the state of rest, t equal to 4 seconds, half a is this much that we have already know, g of sine theta minus mu cos theta, t square is 4 square. So 4 equal to, this is 0, half, g value is 10, sine 30, the angle is given to you as 30, cos 30, 4 square is 16. 1 4 and 1 4 can be cancelled here. This is 5. So how much is this? 5 of sine 30 is half minus mu. Cos 30 is sine 60, that is root 3 by 2 into 4 is there. So 1 equal to 5 by 2, 1 minus root 3 times of mu, and 4 is there. This is twice. Get this 2 to the denominator. 1 by 2 equal to 5 of 1 minus root 3 mu. 1 by 2 is 0.5. Get this 5 into the other side. 5 equal to 1 minus root 3 times of mu. So 0.5 is 5 by 10 by 5 is there. equal to 1 minus root 3 times of mu. 5 and 5 will cancel. So root 3 mu equal to 1 minus 1 by 10, that is equal to 10 minus 1, that is 9 by 10. So the value of the mu equal to 9 by 10 by root 3. 9 by 10 is 0.9, root 3 is 1.732. So if it is 1.8, it could have been half. It is less than 1.8, so it is little more than half. So it's obvious that 0.51, something like that, but you don't have little more than half, only half is available. So kinetic friction cannot be 0.6. This is all wrong answers. This is the right answer. And the static friction is 0.6 and the kinetic friction is 0.5. That's how we solve the problem, and we have used two formulas while we are solving the problem. That at the angle of repose, mu equal to tan theta. When the body is sliding down on a rough inclined plane, acceleration equal to g of sine theta minus mu cos theta. And of course, regular kinematics equation is equal to ut plus half at square. These are the basic equations that we need to use to solve this problem. Just to go through them, and they will be able to understand that further. Thank you.